In this tutorial, we will look at some compositing tools in Flame and get an overview of the different workflows we can adopt when working in Flame. When compositing in Flame, we can either work in timeline-centric batch effects workflow, i.e. promote the shots from the timeline into batch effects to composite them, or work independently from the timeline in the batch-centric workflow on the shot-by-shot basis, like all the other compositing software around, i.e. load the shots directly into batch compositing from the library or the desktop reels. Working from the timeline enables one to see the shots in the context and have a view of the bigger picture, while also being able to tweak the edit and the grade. But before we start, let's have a look at a couple of batch comp setups from the original Mophie Flame project. And that's great about Flame, that we can just open another project, look through it, and import whatever we want into the current project. I will import batch comp setup for shot 40 and shot 190 as an example. So these shots are independent from the timeline, and we can enter batch compositing directly from the media panel. If I double-click on batch comp for shot 40, we can see that this is a pretty straightforward setup. That's only because all the cleanup, tracking, rotoscoping and grade matching has already been done in the pre-comp in Flame. But this is a good example of a basic comp. We have two passes for the shot, one for the actress that has been selected as the best take of her performance, and one for the moving objects that has been selected as the best take of the object's movement. These passes have been shot separately, as it would have been more time-consuming to get the actress's performance and the movement of the objects the way the director wanted in one pass. We also have matte passes that were created in Flame. Now let's have a look at shot 190. We can click on 4 arrows symbol to feed the compositing tree into the schematic viewport. So this comp setup looks a bit more complex, but the compositing trees can grow to this size pretty quickly. We can use Ctrl spacebar to zoom and spacebar to pan around the schematic. We can also use the navigator to quickly move around the compositing tree. We will click on View and under Navigator, click on Display to switch it on. The navigator will help us move around the schematic more efficiently. If we want to zoom into particular parts of the compositing tree, we can Control-click and drag a box within the navigator to have a closer look at the particular part of the schematic. This compositing tree has separate passes for the background that had to be tracked and cleaned up, blue screen animals that had to be keyed, graded and placed on top of the donkey, and different elements for fire to add atmospherics to the shot. When we are creating a comp, we treat individual elements separately and then composite them together. To see before and after, we can command-click on the source clip and from the contextual menu select Set as Next Available Context to create another viewport besides the default ones, and compare the source background clip with the comp result by clicking on spacebar 1 and spacebar 3 hotkeys. We will exit this batch comp so that we can create a comp and have a look at some of the compositing tools in Flame. We will comp shot 90, that consists of the blue screen pass of the reporter that needs to be tracked into the TV monitors. We will click on the shot 90 segments in the timeline, bring up the effects ribbon and click on Create Batch Effects. When we promote the timeline effects to batch effects, we can choose to include the timeline effects done to the clip or not. If we do include them, then the nodes in batch will be connected correctly to recreate whatever was done to the RGB clip and its alpha in a sequence. We can see that the clips are linked to the Batch Effects output node. Batch Effects name in the Media panel is linked to the name of the Batch Effects output node and the clip name. If we change the names of the clip or the Batch Effects node, Batch Effects name in the Media panel will change too. We should never change Batch Effects name in the Media panel, as that breaks the link to the clip and the Batch Effects output node, and therefore the timeline. When we work in Batch Effects, our comps are linked to and get updated on the timeline automatically. Of course, when we work independently of the timeline in batch compositing, the output nodes are independent too. The viewport is currently showing us the schematic view. In order to see our media while we are working on the composite, we will switch to 2-up view. And the schematic is now on the left and the media on the right. We can also change this default setting in the user preferences, so it always loads 2-up view when we enter batch schematic. We will click on the flame logo, select Preferences, Timeline Effects, Batch Effects, and under Batch Effects Defaults, select 2-up. We close the window to return to batch compositing. Before we start, we will bring in a background clip that we can use for the reporter background, as we don't have the original one anymore. I will copy shot 190 background plate by dragging it from the media panel into the batch schematic. In batch compositing editing panel, we have the nodes for an extensive array of compositing tools available to us, organized in different bins depending on the task we wish to perform. In the Matchbox bin, there are additional tools we can use to manipulate, enhance a shot or create visual effects. We will just have a quick look at few effects by connecting them to our reporter background clip. Bleach bypass recreates the optical effect of skipping bleaching during the processing of a color film. When we load into Schematic any Matchbox tool, we can click on Change Shader button and select another Matchbox effect, like fog from the Matchbox Effects menu, that emulates the atmospherics of fog or haze when we wish to create a specific mood in a shot. We can use glow to recreate the optical phenomena of the scattering of colors in the real world. Stingray bloom reproduces the effect of the very bright light hitting the camera or eye that creates fringes of light at its borders. We can create lens refraction that emulates the light refraction of some camera lenses. And we have a choice of different bokeh effects to recreate soft out-of-focus backgrounds that represent different optical lens designs. We can download many more Matchbox effects from the Logic Matchbook website. We will start by working on the blue screen reporter. We will select the schematic viewport and have a look at the node bin. We can view all the tools in the node bin or just go to the Key tab, and the number of keyers and tools associated with keying are displayed. First, we should degrain the blue screen. We degrain a clip so that we get a smoother edge when keying, but also when resizing and compositing an image over another one, as there would be a mismatch in grain between the two images. At the end of our composite, we regrain the degrain clip by sampling the grain from the background clip. We will click and drag the denoise node to the schematic and attach the main output of the clip to its foreground input. Under Grain Analysis, we will click on Add, and the sample box will appear in a viewport that we can position over the flat area of the image to sample the grain and then click Analyze. If we zoom into our image, we can compare before and after by clicking on F1 for the source clip and F4 for the result. We can click on View to view the effect on individual RGB color channels by clicking again on F1 and F4 while selecting them individually and with source isolation selected. We will click to select Display Isolation, select all the channels, and click on View again to return to the Denoise menu. We can still edit a number of parameters like the grain size, radius of blur, and so on, but we will just enter in the Detail field the recommended amount of 0.15. There is also a degrain node we could have used to degrain the clip. Now we will also use Denoise to degrain the reporter background clip. The reporter will be composited over. We are now ready to key. There are a number of keyers to choose from in Flame, and there are tutorials on individual ones on the Autodesk Flame Learning channel on YouTube. We have, among others, Keyer 3D and Modular Keyer, which contains Keyer 3D, and all the additional tools one needs to perform various operations when pulling a key, like 2D histogram, matte edge, Gmask, and despilling operations. But for this tutorial, we will select the master keyer. If we know the name of the node we wish to use, we can just hover with the cursor over the node bin and click on the first letter of the node's name on the keyboard. We will click M for the master keyer, and the selection of nodes starting with M will be highlighted in the node bin. We pick and drag the master key node into a schematic. A warning sign on the node tells us that nothing has been connected to it yet. We will zoom in to have a closer look at the schematic. Our clip has yellow main RGB output and blue alpha matte output. On the master key node, we have red main foreground input, green background input and blue matte input, and yellow result output and blue matte output. We will feed the main output of the blue screen to the foreground, background and matte input of the master keyer. We are not feeding in Denoise clip as the master keyer has degraining function within it. To break the connection between the nodes, we click down and drag across the connection line. If we were working in batch-centric workflow, independently of the timeline, we would change the default duration of the comp by holding the T key on the keyboard and clicking on the source clip. The comp duration would be changed to that of the source clip. As the duration of our comp is set by the timeline, we don't need to do that. As we work in batch effects, we create versions of our comps by clicking on Iterate button. New library is created in the Media panel, where the batch effects iterations are saved. Iterations are also available in the Iterate pull-down menu. Our blue screen clip looks straightforward as the blue screen is fairly even and the actress is not crossing over the tracking markers, so it will be easy to remove them. We double-click on the master keyer to open its parameters in the editing panel and click on the left color pot under Key Colors to select our key color and then click and drag across the blue screen. Both color pots are filled with blue screen color. We click on the right color pot and resample a different area of the blue screen. To view the result of the master keyer, we click on F4. We can then mix between the two to get the best result. If we hover with the cursor over the media viewport and hold Alt key, the sliders come up that display different parameters as we move them around our image. We will click down in the viewport and start adjusting matte overall effect. Once we are happy with the tweaks, we click underneath the image to discard the slider. Under Sampling, we will change from matte to Patch 1, and in the viewport, click and drag on the blue regions that still need to be keyed. We can then select Patch 2 and click and drag on the regions outside the blue screen to fill in the holes in the regions we don't wish to be keyed. The master keyer has automatically dispelled the blue screen, but we can still sample the spill color and change the dispelling color in the color trackball. We can also degrain the blue screen by selecting Degrain under Sampling menu and sample the grain by control-clicking over the flat area of the blue screen. Degrain becomes active and we can still adjust its size and edges. Once we got a good matte out of the image, we can use Gmask Tracer and animate it to get rid of the tracking markers. We will drag Gmask Tracer to the schematic and connect the main output of the master keyer to Gmask Tracer main input. Gmask Tracer has its own schematic, which we can access through the viewing list. The camera is automatically added as Gmask Tracer is based on Action 3D compositing. We drag Gmask to the Gmask Tracer schematic, and Gmask has an axis attached to it, and the tools automatically switch to Draw Shape. We will now draw a mask around the reporter by clicking around her, or by clicking and dragging to create a smooth mask. We close the mask by clicking on the first point we created. In Tools drop-down menu, we have additional options to modify our mask, like A to add points, B to break tangents, D to delete, and M to select. In the Output tab, we have options to output different passes and also comp or matte. If we click on the matte output and press Escape, with schematic viewport selected, to go back to our batch schematic, we can see that Gmask Tracer has only matte output, until we click on comp output in the render passes to enable it, and then a comp output is added. We will select Gmask Tracer schematic from the viewing mode or click on tilde key to return to it. With Media Viewport selected, we will select Gmask Tracer inputs, Media Front, in the viewing mode, or click on F1. To animate Gmask, we go to Gmask Tracer menu on the right and switch on Auto key. We can now adjust the shape and the position of the Gmask at different points of our clip in a timeline, and the keyframes of the animation will be created. If Gmask needed tracking, we would select the axis and go to the Object Tracking tab, where we have the option to choose between Track, Stabilize or Planar. We will select Track, leave Rotation and Scale off, and enter Tracker. The tracker is automatically positioned at the center of the Gmask. We will place it at one of the tracking markers, and in the editing panel, we can choose to analyze forward or backward. We will leave the selection on forward and click Analyze. Once Flame has processed the track, we can offset it so that it is back in the center of our Gmask. We can now click on the Return button. If we wanted to still tweak its position, we could add another axis to it. To see the animation editor, we swipe to the right. At the bottom of the editing panel, we have access to the priority editor that we can use to change the priority of the multiple Gmasks. We will invert the Gmask and in the output menu, change the render passes blending from keep to override and change the blend mode to subtract. We can't see anything because we haven't connected master keyer matte output to Gmask matte input, so we will return to batch schematic to do that. There is much more to GMask Tracer though. It is an incredible tool for both masking and keying. So let's have a look at its keying capabilities. We will add another GMask Tracer and connect the main output of the Denoise node to GMask Tracer main input. We will go to GMask Tracer Schematic and add a Gmask. To view GMask Tracer output, we will click F8 and go to Object tab. In the Tracer menu, under Analysis, we click Add and two color pickers appear in the viewport. We will position the green color picker on the blue screen area and red color picker on the reporter. We will click on F8 to view the result of the Gmask Tracer key. The position and the size of the color pickers influence the result of the Gmask Tracer key. We can add more color pickers by clicking on Add Background or Add Foreground and finesse the matte more. Under Softness, we can adjust background and foreground softness, and under Post-Processing, we can shrink, dilate or blur the matte. We are now ready to go to the Output menu, name our output to Gmask Tracer key, and under Render Passes, keep Comp switched off, keep Matte only, and press Escape to go back to Batch Schematic. We will now tidy up the schematic and create some space for our nodes. We will go to the Tools menu and select Draw Compass tool. We will draw them around different sections of our schematic tree, name them and assign a color to them. I will leave those not relevant to our comp gray and assign a color just to sections of our schematic tree that make up the comp. When we finish our comp, we will add elbows to keep the lines between the node connections straight. It is important to keep the schematic tidy, as another artist may have to pick up our comp, or we might have to return to it to create changes or different versions. When we key a clip, we normally treat the key and the foreground separately and don't actually comp within a keyer. Every pass is treated separately, the background, the foreground and the matte. That way we have much more control over our images. For our key, we will use just the matte output from our master keyer and the Gmask attached to it. The master keyer has already despilled our clip, and we could just copy the master keyer node and use it as despiller only for our foreground blue screen clip when we feed it into our comp later on. However, we will use color curves node to dispill our clip. We will drag color curve node from the node bin and attach it to the denoise blue screen. Under Curves menu, next to Suppress, we will click on the color pot and sample the blue screen from our image by clicking on Pick and clicking on the blue in the viewport. Red line appears in the color curve graph that matches the hue of the blue screen, and we can just pull down the curve at that point to suppress the blue. We will add a compass around this spill, name it and color code it. When we create a comp, the green screen or blue screen of the foreground clip can show through the soft edge of our key mat by pixel or two. This is particularly obvious if the blue screen or green screen is darker than the background image the clip is composited over, and we end up with a dark edge. We can fix that by adding pixel spread to extend the color information beyond the edge of the mat for few pixels. We will feed our despilled foreground into the main input of pixel spread, which has an additional input for motion vectors that we are not using. And we will connect Gmask Tracer output of our foreground key into the matte input of the pixel spread. We will set spread type to parallax and spread mode to expansion. Amount is by default 1, and we will change it to 5. We can zoom into the image and click on F1 and F4 to compare before and after. We can now add a comp node and feed into the main input the output of pixel spread, to the background input the reporter background clip, and to the matte input Gmask Tracer output of the master keyer. We will add a max node and freeze the background reporter clip on frame 1, and we should also select repeat last under after. Before we track the background, we will remove the tracking markers to prepare the plate for the reflection pass we will comp in later. There are many ways to remove the tracking markers. Most often, we just need to create a clean frame and track it in. Because our shot has moving reflections, we can't do that. So we will have a look at a couple of alternative ways for removing the trackers. One by offsetting the clip through the tracked Gmask, and another one by using color correction and blurring through the tracked mask. We will add an action node and connect the background clip to it. Action is Flame's 3D compositing tool that has its own action schematic and its own node bin with specialized 3D tools. In Action Schematic, we will add the Gmask and draw around a tracking marker. We will click on the axis and in Object Tracking, keep selection on Track and enter Tracker. We will position the tracker at the edge of the tracking marker. We will keep Auto Update Reference on and Analyze Forward. Once the track is done, we will click Return to exit the tracker. We will click and drag the background clip from the Media panel. Select Gmask node and invert it. We will select Clip Axis node and offset the clip's position on X and Y so that it is in a different position to the layer below of the same clip and so covers the tracking markers. We will add another axis and connect it to the Gmask axis to place the Gmask into position. We tweak the background axis a bit more and add soft edge to Gmask by clicking A to add points in the Tools menu and then clicking Shift and pulling out its edge. So we have just offset the clip through the tracked mask. Because of the reflections moving, this isn't working, but it is a good technique to keep in mind. We will return to Batch Schematic to look at another technique. We will first change the color of the tracking markers using Color Warper, which can both key the trackers and color correct them. We will add a Color Warper node and connect it to the background clip. In Color Warper, we will select Selection 1 under Work on menu and click on R under Define menu. The tracking markers are now isolated and we can desaturate them by bringing down saturation and darken them by bringing down gamma. We will add a blur node and connect Color Warper main output to the main input of the blur node and the action node matte output to the matte input of the blur node. We will click on blur node and increase the blur. The whole image is affected, so we need to click on Use Matte, and now only our tracking marker is blurred. So I have repeated this same process and removed the rest of the tracking markers by adding more action nodes and Gmasks so that they can be color corrected and blurred individually. We can now play the result of our cleaned reflection pass, and if we need to finesse anything, we can return back to it later. In Flame we can track, stabilize or planar track, either axis, Gmask or perspective grid. We can also track a camera. Our shot has moving reflections, so we can't use planar tracker. Instead, we will use 4-point corner tracker using bilinear surface. We will add an action node from the Effects node bin and connect the background clip main output to the background of the action node. We will click Ctrl N to add another media input to action, bring in Color Source node and connect it to the main input of the media input. We will double click on the Color Source node to reveal its parameters, and from the drop-down menu select Pal Bars. We will double click on the action node and enter Action Schematic. Our bars image is loaded with an axis attached to it. We will select the image and in the Object Surface menu change its type from flat to bilinear. We will click on Vertices tab and enter Stabilizer. We will position the trackers at the corners of the main monitor. We will keep selection on Gang, keep Auto Update Reference on, and click on Analyze Forward. Once the track is done, we can check it in the timeline. We can see that Tracker 1 is having problems because of the bright reflection coming in, so we will change the selection to Solar and select Tracker 1. We can use Backspace key on the keyboard to delete the tracking points until we get to the last good point in the track. We will then move the clip in the timeline to the next reference point we wish to use to continue our track. In Tools menu, we select Add Points or click A and Control move our tracker to its position at the corner of the monitor. We click Analyze again and the tracking is holding much better now. We change to Gang Selection and click Return to exit the stabilizer. We will click on Iterate button to save our comp. And we will click and pull the corners of our bilinear image to place it in the monitor. We can now play the clip to check how the track is holding. Tracker 1 position is distorted, so with Auto key on, we can make adjustments to the bilinear image along the timeline. We will zoom in to have a closer look. In Object Surface, we will increase the transparency so that we can see better the edge of the screen. We will tweak a bit more. Of course, the problem we will have later is that the tracking markers are on the rim of the monitor instead of being in the corners of the screen, meaning that we will have to use the cleanup that we created for the reflection pass as the background plate. We will return to BUD Schematic. Disconnect the color bars from the media input and connect the reporter comp to it. We will return to Action Schematic and remove the transparency. And play the result. Of course, we have black bars each side, which we need to remove. So we will return to BUD Schematic fit the image in the viewport by clicking on 4 arrows and zoom into the schematic. We will go to Effects Node bin and bring in a Gmask. We will connect the main output of the comp node to the main input of the Gmask. And go to Gmask Schematic. We will draw a shape around the image and click on B to break its tangents. We will return to BUD Schematic and connect Gmask output to Action Media Matte input. We'll click on Action Node and return to Action Schematic. We could crop the clip in different ways, but we will simply scale it on X-axis, clicking the proportional resize off to fit it into the monitor shape. And we will also tweak its position. We will return to BUD Schematic and disconnect the background from Action by clicking and dragging across the connection line and attach the cleaned up background to Action. We will add another comp node to add reflections and connect the clean reflection path to the main input of the comp node. Switch on comp output in the Action node and connect it to the background input of the comp node. We will switch blend type to screen and adjust the transparency. We will play the clip to see the result. The screen is slipping, so we will need to make some adjustments. First, we will connect the matte output from Action to the matte input of the comp. We will return to Action Schematic, select the axis, and in Object Axis, make changes to the position of the screen image. We will save the iteration of the comp and play the result again. And this is much better. We will now return to BUD Schematic. We will disconnect the Batch Effects node from the previous comp node and connect it to our new comp. We'll bring in another comp node and click and drag the graphics into our schematic. We will attach the reporter comp into the background input, the foreground graphic into the foreground input of the comp node, and the graphics alpha pass main output into the matte input of the comp node. We will add a color correct node after the foreground graphic and adjust the saturation of the graphics. We will go to Action Node Preferences, and in Node Preferences, Rendering, under Accumulation, enable Motion Blur. We will change samples to 10 and increase the shutter speed to 2. We will bring in Matchbox node and attach it to the Reporter Graphics comp. We will load Effects Fog Shader and reduce its gain to 20. We will then add Damage node and connect Fog Shader output to its main input. We will change Damage type to Digital Video and switch on all the digital effects besides color artifacts by clicking on individual LED signs. We will reduce the spacing of digital drops to 7. We will switch off chroma errors and pixelation. And lastly, we will add the regrain node and feed the comp into its main input, and Action Matte output to the matte input, and feed the comp into its background input. In Regrain node, we will click on F2 for background view and sample the grain by clicking Ctrl and dragging over a flat area of the image. We can zoom in to have a look at before and after. We will tidy up again, and from the Tools menu, select Draw Compass tool and draw it around the graphics section of our schematic tree. Name the compass and assign a color to it. We will then add elbows by clicking A to select Add Points in the Tools menu, and then touch on the nodes connection lines where we wish to add them. Our schematic is now pretty tidy. We will now save the iteration of our comp by clicking on Iterate button. If we had been working independently from the timeline, we would now attach a render node, name it, click Render, and our comp would be displayed in the Media panel in the Batch Rails, Batch Renders. But as we are working from the timeline, we can just return to the timeline and render our shot in the timeline. By right-clicking and selecting Render. Of course, this shot is not finished, and there are plenty of other monitors left to place the reporter in. Flame is the most sophisticated compositing software around, and in this video we have only been able to touch upon its compositing workflow. There are more advanced Flame compositing tutorials and Flame presentations on the Autodesk website and on YouTube. In the next video, we will have a look at exporting and archiving our project. For more in-depth tutorials on the individual Flame tools, please go to Autodesk Flame Learning channel on YouTube.